5-3. X and Y intercepts. If you're looking for the X intercept, plug in a 0 for the Y. If you're looking for the Y intercept, plug in a 0 for the X. Domain is side to side. Range is up and down. If there's no denominator and you're looking for the domain, it's going to be negative infinity to positive infinity. Equal sign, there's always going to be a union. And when there's a square root, there's always going to be a union. If the square root is in the denominator. The slope of a line is y2 minus y1 over x2 minus x1. Horizontal line has a slope of 0. Vertical line has a slope undefined. If you have to write something in y equals mx plus b form and you have 2 coordinates and a slope, you do y minus y1 equals slope times x times x1. If you're looking for the parallel, it's going to be the same exact thing. And if you're looking for perpendicular, you're going to flip it and make it negative if it's positive. A vertical shift up or down is going to be on the back side of the parentheses. If you're looking for a horizontal shift left or right, it's going to be the second variable that's inside of the parentheses. A vertical stretch or shrink is going to be the variable that's right before the parentheses. A horizontal stretch or shrink is going to be right next to, it's going to be the first variable in the parentheses. And then if you have a negative, it's going to be a reflection. If you're looking for something that's symmetric with respect to the y-axis, you're going to plug in a negative x. And if you're looking for something that's symmetric with the x-axis, you're going to plug in a negative y. If neither one of those work, then it's symmetric with respect to the origin. If you're determining if the function is even or odd or neither, you plug in a negative for the x value. And if it's the same thing, when you finish plugging it in, it's even. If it's the exact opposite, it's odd. And if it's neither of those, then it's neither. If you're looking for f of g, it's g of, you're going to plug in the g for the x value for the f solution. If it's g of f, the f goes into the g. If it's f of g, the g goes into the f. And if it's g of f, the f goes into the g as the x values. Inverse functions, you can do a horizontal line test. And if you're determining if the relation defines y as a one-to-one function of x, it cannot have the same y values. If you're looking for the inverse, you're just going to flip the x and the y's when it's a one-to-one function. And if you're determining whether two functions are inverse, you're going to plug in the g where the x value is supposed to go. Also, if you're determining if the relation defines y as a function of x, if it has an even root, then it's not a function. And if it has more than one x value, more than one of the same x values, then it's not a function.